Imagine yourself standing amidst a vast ocean of existence, where everything around you vibrates with profound secrets, and the cosmos whispers tales of impenetrable barriers. This is a realm where humanity, driven by an unquenchable curiosity and a fervent desire for mastery, is perpetually restrained by two invisible walls, two insurmountable obstacles seemingly etched into the very fabric of reality by its inherent nature. One wall looms overhead, known as the speed of light, a limit that no entity can surpass, no matter how fiercely one propels oneself into the infinite void. The other lies at our feet, chilling and silent, bearing the name Absolute Zero, an abyss that remains forever out of reach, regardless of how deeply one is enveloped in layers of unrelenting frost. These boundaries are not mere arid figures in textbooks. They serve as poignant reminders of our fragility within an expansive universe, where stillness can evoke the deepest terror, and motion holds the key to all vitality. Allow me to guide you through this journey at a leisurely pace, akin to a river meandering through enchanted landscapes, where each detail evokes vivid imagery and stirs profound emotions. The speed of light, approximately 300,000 kilometers per second, stands as the upper threshold, resembling an ceaselessly flowing river that one cannot overtake, no matter the effort expended. It renders us diminutive, yet it ignites awe at the universe's harmony, where light propagates like an eternal symphony. In contrast, Absolute Zero represents the lower extremity, where all motion ceases and the cosmos appears frozen in an everlasting instant. The core of the Sun, reaching temperatures of 15 million degrees Kelvin, is sufficiently scorching to vaporize any matter instantaneously, like a blaze consuming all in its fury. Yet Absolute Zero proves infinitely more formidable, not through incinerating heat, but because it acts as a pause button for the entirety of existence. There, chemical reactions halt, time loses its significance, and even light thickens, sluggish like congealed syrup, instilling a profound sense of isolation in the heart of quiescence. The most intriguing aspect is that the universe appears to have engineered a special mechanism to thwart our approach to this point, concealed within the fundamental code of reality. Have you ever pondered, with a blend of curiosity and faint trepidation, how our forebears, lacking the sophisticated instruments of today, discerned the presence of such a frigid infernal gateway in the cosmos? Let us journey back over 2 centuries to a modest laboratory in France, where the atmosphere hung heavy with the scent of gas and the crackling of flames. A scientist named Joseph-Louis Gay-Lussac, with dexterous hands and a keen intellect, conducted a simple experiment that a schoolchild might replicate, yet its outcomes reverberated through the scientific community like a silent earthquake. He merely heated and cooled various gases, meticulously recording changes in volume, while the surrounding air seemed to murmur cosmic secrets. Upon connecting the data points, a terrifying trend emerged. Irrespective of the gas, as temperature decreased, volume contracted at a fixed ratio, akin to a straight line plunging into obscurity. More alarmingly, extending that line intersected the horizontal axis at minus 273 degrees Celsius. What did this signify? It implied that at this temperature, the volume of the gas would reduce to zero, vanishing utterly without trace, like a soul dissolving into nothingness. Gay-Lussac, his heart pounding with the thrill of discovery, immediately recognized that this was not a point where matter truly disappeared, but a glaring red warning line drawn by the universe in mathematical language, a boundary beyond which reality would crumble like a sandcastle before an encroaching wave. In truth, this finding intertwined closely with the law of Jacques Charles, who had earlier uncovered the relationship between volume and temperature. But Gay-Lussac expanded and refined it through experiments on pressure and temperature, laying the groundwork for the ideal gas law. Following countless precise measurements by subsequent scientists, this deadly coordinate was fixed at minus 273.15 degrees Celsius. This is Absolute Zero, the universe's supreme forbidden zone, calculated solely with pen, paper, and unwavering perseverance. But why is it locked at this precise figure? Does the universe favor rounded numbers for mnemonic ease? The reality is more Diendal than imagined, evoking a sense of wandering through a labyrinth of illusions. This number exposes the arbitrariness of human-devised scales, while affirming the absoluteness of cosmic laws. The Celsius scale we employ daily merely anchors to the freezing and boiling points of water, like a familiar yet limited measuring rod. In the Kelvin scale, however, absolute zero equates to 0 Kelvin, a true origin from perfect stillness. Now that we possess the coordinates, let us confront this dread together, our hearts trembling before its mystery. Why does absolute zero inspire such profound fear? Do not compare it to the Antarctic or Arctic, where howling winds and falling snow still harbor a whisper of life's warmth. Beside absolute zero, they resemble tepid springs. The temperatures we perceive daily are, at their essence, the degree of frantic motion among atoms, like a chaotic dance of minuscule particles. When boiling water, molecules cavort exuberantly, disseminating heat like an unending revelry. Upon freezing, they stand rigid as if penalized, forming a cold solidity. But at absolute zero, every atom in the universe is compelled to absolute immobility, frozen like stone statues in a forsaken garden. Envision being abruptly cast into such an environment, with the final whistle of wind echoing in your ears and your breath solidifying mid-exhalation. The trillions of cells, the innumerable atoms composing you, would freeze in a fraction of a second, not gradually congealing, but as if a video were suddenly paused. Your thoughts, your pounding heartbeat, the flowing blood, all would fail to emit their final signal before you transformed into a cosmic amber block, preserving your last posture for eternity, enveloped in perpetual solitude. With no atomic motion remaining, bacteria could not decompose you, and you would persist eternally in flawless preservation, like a sealed treasure in darkness. But is this immortality? No, it constitutes the universe's cruelest paradox, evoking a deep melancholy at its futility. The cosmos bestows eternity, yet strips away the capacity to perceive it. You exist, yet forever unaware of your existence, like a dream from which one never awakens. And if you deem this merely a physical horror, you underestimate the universe's boundless imagination. As temperature nears this forbidden realm, the tangible world begins to fracture, physical laws invert, and matter performs miracles that prompt doubt of one's own reality, blending curiosity with surging dread. The first miracle is termed the immortality of electricity, a phenomenon that makes laboratory air seem to vibrate with enigmatic energy. In 1911, the Dutch scientist Heike Kamerlingh-Onnes, in a frigid laboratory resounding with machinery, cooled mercury to 4.2 Kelvin, approximately minus 269 degrees Celsius. Astonishingly, mercury's electrical resistance vanished abruptly, like sorcery from another realm. Current flowed without loss, potentially circulating forever in a superconducting loop, akin to an endless river in obscurity. Theoretically, throughout the cosmos, every current contends with heat-generating resistance, but superconductivity shatters this rule, like a cheat code in physics. Today, technologies such as magnetic resonance imaging machines, with their humming noise and life-saving crisp images, or magnetic levitation trains gliding smoothly on tracks, harness this principle. Yet this is merely the prelude. The latest updates to 2026 reveal, with artificial intelligence's aid, scientists have uncovered novel superconducting materials, including those exhibiting Type 3 superconductivity, where superconducting islands persist amid non-superconducting regions, and finite momentum superconductivity in twisted bilayer molybdenum disiluride, promising enhanced quantum technologies and more efficient energy transmission, kindling a glimmer of hope amid the chilling shadows. The second miracle is even more bizarre, known as liquid helium superfluidity, a fluid behaving like a phantom in the material world. When helium is cooled to approximately minus 271 degrees Celsius, specifically 2.17 Kelvin for helium-4, it becomes a liquid devoid of viscosity,
capable of climbing walls, surmounting barriers, and flowing autonomously without propulsion, like a wandering spirit in the night.
Placed in an utterly sealed vessel, it still permeates atomic-scale crevices, leaving early observers feeling as though the laboratory were haunted with the whisper of liquid moving in silence. This phenomenon is superfluidity, and recent research on helium-3 superfluidity discloses paired particles dancing in space, offering deeper insights into quantum properties, even assessing the feasibility of topologically protected quantum computers. Recent advancements in 2025 include discoveries of a universal law governing quantum vortex dynamics in superfluid helium, where tiny frozen deuterium particles visualize invisible vortexes, and models mimicking vacuum tunneling in two-dimensional superfluids, simulating cosmic phenomena like matter creation from nothing, evoking wonder at the universe's ingenuity. If you consider this sufficiently mad, brace yourself, for the ensuing phenomenon will utterly upend your worldview, with astonishment surging like a storm. In 1995, humanity forged the fifth state of matter, termed Bose-Einstein condensate, in a laboratory where icy air and echoing lasers prevailed. Thousands of atoms, chilled to near zero Kelvin, suddenly forfeited individual identities, moving in perfect synchrony, as if governed by a singular collective soul, like a cosmic choir singing in harmony. This is not mere order, it is profound unification, where atoms merge into one entity. Progress since includes generating Bose-Einstein condensates in space via the Cold Atom Laboratory on the International Space Station, where low gravity enables more precise studies, unveiling windows into quantum physics and potentially yielding ultra-sensitive quantum sensors. By 2026, breakthroughs encompass long-lived molecular Bose-Einstein condensates with dipolar properties, first observations of Bose-Einstein condensation in two magnon-bound states, and atomic Josephson junctions at 30 nanokelvin, advancing quantum simulation and materials research, stirring pride in humanity's exploratory spirit. You might inquire, with curiosity mingled with hope, whether any locale in the universe truly attains such coldness. Indeed, some surpass the universe's average temperature. The Boomerang Nebula, 5,000 light-years from Earth, registers approximately -272 degrees Celsius, merely 1 degree Kelvin above absolute zero, colder than the cosmic microwave background at -270 degrees Celsius. This gas cloud, ejected from a dying star, expands at 500,000 kilometers per hour, cooling rapidly like a deflating balloon, with cosmic winds howling through the void. The cosmic microwave background, the Big Bang's echo, pervades like a gentle background melody, but the Boomerang Nebula chills further, like a prophecy from the future, disclosing the merciless decree that the universe veers toward inescapable extreme cold. This leads to one of physics' most despairing laws, weighing heavily on the heart with sorrow for the end. Heat invariably flows from hot to cold, until all succumbs to entropy's icy quiescence. Stars will exhaust their fuel, black holes evaporate via Hawking radiation, and when the final star extinguishes and the last black hole fades, energy ceases to flow, chemical reactions halt, and time loses meaning. This terminus is the heat death of the universe, and absolute zero epitomizes its ultimate form, not mere low temperature, but existence's cessation, prompting reflection on life's fleeting meaning. Nevertheless, theories to 2026 contend that heat death is not inevitable. Novel interpretations of thermodynamics suggest life and organization may persist, with entropy potentially reversible in certain scenarios, igniting hope amid despair. Recent models propose the universe might end sooner than anticipated, or via alternatives like a big rip or cyclic rebirth, challenging traditional views and fostering ongoing debate. Now, returning to the initial query, enveloped in mystery, why does the universe erect this wall? Perhaps the speed of light and absolute zero are the supreme chains the cosmos imposes on all civilizations, locking space and time, confining us to isolated islands in vast space-time. The speed of light bars interstellar travel, while absolute zero thwarts true immortality. Yet humanity never ceases striving, with burning courage. We employ superconductivity to defy the cold, and probe spacetime through instruments like the James Webb Space Telescope, each advance a glimpse of cosmic truth. Should we one day breach this taboo, time might reverse, birthing a new universe. We know not, but it would rewrite physics and philosophy. Until then, absolute zero hovers, like a mirror reflecting the universe's final stillness and humanity's daring dreams despite impossibility. This silent, icy abyss draws nearer each moment, and every faint ray toward it measures civilization's resilience etched in darkness, arousing endless curiosity about hidden secrets. Finally, I extend sincere and profound gratitude to all scientists, researchers, and collectives contributing to this exploratory journey. We owe boundless appreciation to Joseph Louis Gay-Lussac and Jacques Charles for their pioneering experiments on gas laws, quietly unlocking the door to absolute zero with steadfast persistence. To Heike Kamerlingh-Onnes for discovering superconductivity, offering hope for future technologies. To researchers on superfluid helium, such as those at Cornell University and Royal Holloway, University of London, illuminating bizarre phenomena near the forbidden zone. To Eric Cornell and Carl Wieman for creating Bose-Einstein condensate, expanding matter's boundaries. To astronomers studying the Boomerang Nebula and cosmic microwave background, like teams at the Atacama Large Millimeter Submillimeter Array and Planck mission, revealing the universe's coldest sites. To Brandon Carter and David Deutsch for profound reflections on the anthropic principle and cosmic consciousness. To theorists like Lee Smolin with ideas on cosmic evolution, and recent groups employing artificial intelligence to unearth new superconducting materials, including those advancing Type 3 superconductivity and molecular Bose-Einstein condensates. To all who have tirelessly dedicated time and effort, enriching humanity's knowledge treasury and illuminating society amid ignorance's shadows. Your silent devotion inspires eternally, drawing us nearer to comprehending the universe and ourselves.